Welcome to the DIY Honda Garage channel. The DTC P0335 indicates a situation where the crankshaft position CKP sensor is not sending a signal to the powertrain control module PCM. This sensor is crucial as it monitors the position and rotation of the crankshaft, enabling the PCM to control ignition timing and fuel injection. An absence of this signal can lead to engine misfires, no start conditions, or erratic engine behavior. The CKP sensor is typically located at the engine block near the crankshaft pulley. When the CKP sensor fails, or if there's an issue in its circuit, the PCM recognizes this discrepancy and stores the DTC P0335 as a warning to the technician. Proper diagnosis is essential to pinpoint whether the fault lies with the CKP sensor itself, its connections, or the PCM. The crankshaft position CKP sensor plays a vital role in the engine management system. This sensor detects the rotational position of the crankshaft, which is essential for determining the precise timing of fuel injection and spark ignition. Its placement near the crankshaft pulley allows it to monitor the crankshaft's rotation effectively. When the engine is running, the CKP sensor generates a pulse signal that is transmitted to the powertrain control module, PCM. If the PCM does not receive this pulse signal, it registers a fault and sets DTC P0335. Judging by this DTC, the issue often lies either within the CKP sensor, its electrical connections, or the PCM circuit itself. Thus, proper understanding of the CKP sensor's operation and location is crucial for fruitful diagnosis and repairs. There are several potential causes for DTC P0335. A faulty crankshaft position CKP sensor is the primary suspect. If the sensor has failed, no signal will be sent to the PCM, which will trigger the DTC. Additionally, open or short circuits in the wiring harness associated with the CKP sensor can prevent proper communication between the sensor and the PCM. Lastly, a malfunctioning PCM might also be the underlying issue if all other components appear to be functioning correctly. Each of these scenarios requires careful inspection and testing to identify the actual source of the problem. Understanding these potential causes helps technicians efficiently direct their troubleshooting efforts to resolve the issue. Several symptoms can arise from a DTC P0335 situation. An engine may exhibit misfires, which occur when the timing for fuel injection and ignition is impaired, leading to inefficiencies in engine operation. A no-start condition is another likely symptom, as the PCM may disable the engine if it perceives a critical sensor failure. Erratic engine performance, where the engine behaves unpredictably, can also manifest due to irregularities in the signals sent to the PCM. These symptoms not only affect vehicle drivability, but can also lead to further fines in engine health if not addressed promptly. A thorough understanding of these symptoms aids technicians in correlating the symptoms with the possible causes effectively. The first troubleshooting step for DTC P0335 involves starting the engine to gather basic operational data. By running the engine, technicians can determine if the CKP sensor is generating the expected pulse signal while the vehicle operates. It is crucial to monitor the PCM's response during this step, as it will directly impact ignition timing and fuel injection. If the engine runs, but the PCM does not receive a proper CKP signal, this would confirm a fault with the sensor or its circuit. This straightforward initial step sets the stage for identifying whether the issue lies with the CKP sensor itself or in the broader circuitry associated with it. In the second troubleshooting step, focus shifts towards inspecting the CKP sensor directly. Check that the sensor and its connector are intact and free from any physical damage or corrosion, as this can severely hinder the connection. It's also essential to verify the voltage output from the sensor by using a multimeter in IG mode. When functioning correctly, the voltage output should be around 5.0 volts. If the output deviates from this value, it is highly indicative of a malfunctioning CKP sensor. Completing this inspection can help isolate the issue further, allowing for subsequent steps to address any identified faults. The third step in the troubleshooting process involves a thorough inspection of the wiring and circuits related to the CKP sensor. Start by examining the VCC1 circuit and ensure it is free from open wiring conditions, as the circuit provides power to the CKP sensor. Next, verify that the CRKP signal wire is intact and conducting properly. Any breaks or damage can inhibit signal transmission to the PCM. Lastly, check the SG1 ground connection to ensure the CKP sensor has an adequate reference ground. This is critical for proper sensor operation. These steps are essential in pinpointing electrical faults that could lead to DTC P0335 issues, helping technicians understand where to focus their repair efforts. In the final troubleshooting step, the focus shifts to the powertrain control module, PCM. If previous inspections conclude that the CKP sensor and its circuits are functioning correctly, the next logical step is to evaluate the PCM itself. Using diagnostic tools like the HDS, Honda Diagnostic System, check for any stored faults within the PCM. If no additional faults are present and the PCM appears to operate normally, this could indicate that the PCM is indeed the source of the problem. Conversely, if errors do appear, it's essential to address them, as they may point to underlying issues needing resolution before concluding the DTC P0335. Properly diagnosing the PCM ensures targeted repairs and restores optimal vehicle function. After completing the necessary repairs based on the diagnostic findings for DTC P0335, it is imperative to run a final verification process. Begin by clearing the DTC from the PCM to reset any fault codes that were present. Following this, conduct a test drive to ensure the vehicle operates as expected under various driving conditions. During the drive, closely monitor for any reappearance of the DTC or symptoms that suggest the issue has not been resolved. This step validates that the repairs made were effective and ensures that the vehicle is functioning correctly. Successful verification instills confidence in both the technician and the vehicle owner that the problem has been conclusively addressed. To prevent the recurrence of issues related to DTC P0335, implementing a solid preventive maintenance plan is critical. Routine inspections of the CKP sensor and its associated wiring can catch early signs of degradation or damage before they lead to more significant problems. Additionally, regularly checking the integrity of wiring harnesses helps prevent open circuits or shorts caused by wear and tear. Performing comprehensive system diagnostics at regular intervals allows for the early identification of any potential issues, ensuring the engine management system remains fully operational. By committing to these proactive maintenance steps, vehicle owners and technicians can enhance vehicle reliability and performance over time. In conclusion, diagnosing and resolving DTC P0335 requires a thorough understanding of the crankshaft position CKP sensor's role within the engine management system. Following a systematic troubleshooting process allows technicians to pinpoint the exact cause of the signal loss, whether it be a fault in the sensor, circuit, or the PCM itself. By meticulously inspecting the components involved and verifying the repairs, technicians can ensure that the vehicle runs smoothly without recurrence of the issue. Implementing preventive maintenance measures can also significantly mitigate the risk of encountering this problem in the future. Ultimately, addressing DTC P0335 enhances vehicle performance while ensuring reliability for the driver. Please like and subscribe to the channel. See you next time.